time is another day. And when you have cancer, every day is a gift. And so having one more day is that blessing. I had relapsed with acute lymphoblastic leukemia. It was the third time. And so chemotherapy just wasn't working. My body had built up a resistance. I was being left with very long-term side effects. When I exhausted everything, it led me to have to pursue clinical trials, to pursue immunotherapy as a possible option.
She had bad leukemia that was refractory to everything people could give her, and nothing could get her into remission. And so, I mean, that she's a challenge, right?
With the immunotherapy, why not trying to use my immune system to fight cancer and see if maybe that could work? And even if it couldn't, I knew that it was going to help research pave that way for the future for other cancer patients.
It wasn't that long ago that sequencing started to take off, but since then, the amount of data that's been generated since that time has grown exponentially. And being able to actually work with that data and turn it into insights, it's a whole new field.
So we're really trying to answer key questions by looking at large amounts of data.
And the big overall question is, how can we get this therapy to work for patients?
The reality is that maybe the answer is in these data, and the only way to unlock that will be using sort of new computational methods to extract information.
Again, these numbers are not just numbers. They are people's stories.
The thought, of your impending death is something that you have to try to think about. And a lot of things that you think are so important when you're not battling cancer really don't matter. Out of your brokenness, you rise above, you learn how much internal strength and resilience you can have if you want to.
Science is moving a lot. You can still do it and you can be in different buildings, but it slows things significantly.
And so we now have the opportunity with the leasing of the steam plant where we can actually bring these scientists together in a unique environment that we currently don't have, where the labs are all open lab spaces and where computational biology groups will be adjacent to biology research labs and immunology research labs, and really get the people working together.
The problems that they're discussing are so complicated that it's not the kind of thing you get together for an hour and say, okay, we got it, we'll see you next month, right? It's the kind of thing that happens on a day in, day out basis. And so what we want to provide at the steam plant is an environment that's going to be as permissive for those types of collaborations as possible. We're trying to provide resources, we're trying to provide space, we're trying to provide state-of-the-art instrumentation and technology. And so by bringing those different types of people together, particularly data scientists, enables the types of experiments that probably would not be conceived of.
They're kind of at the cutting edge of their computational field, and we're trying to understand what's happening, with our different therapies, and being able to talk kind of back and forth with them of, is this a question we can answer? And they'll be like, well, I don't know, let's see if we can go around and tweak our algorithms. And oftentimes, they don't even know that there's a need for answering some question unless we bring it to them.
And it's something that can only happen by interacting directly with the people that care about this data in a different way beyond just numbers. So I think the work that's going on here at the Hutch in the computational sciences and the experimental sciences and the clinical sciences are all coming together into this convergence point to make something completely new.
That bag of cells going into me, if it was going to buy me a day, a week, a month, 2 months, that is a blessing.
This process is really like your immune system fighting off the flu.
So we would take patients who had failed all other therapies and treat them with a single dose of these engineered T cells, and often within 2 to 3 weeks, every sign of cancer had disappeared in their body.
I would say within a month after infusion, I could have easily gone back to resuming work.
Now, to see that, I think none of us, as optimistic as we were about this therapy, none of us actually had expected the results to be that dramatic.
And I remember I told Dr. Maloney I would do this 1,000,000 times over chemotherapy.
And it's very likely that within the next few years, you won't be talking about bone marrow transplants or other kinds of options in some cases, and maybe be using CAR T cells instead of chemotherapy.
So I think where we're going to be accelerating the science is going to be happening in the STEAM plant. It's going to be an incubator because we're taking all these people from different fields, putting them together into the same room and asking, what's the next step to get us to the next cure?
And that's the team of people that we need now to take the underpinnings of immunotherapy, which is still in its discovery stage, and to translate those discoveries into taking care of not just patients with blood cancers, but patients with colon cancer and breast cancer and prostate cancer and pancreatic cancer, and extend the cellular therapies to tens of millions of people. The government doesn't fund the sort of innovative, high-risk, high-reward transformational work that we're trying to build at the STEAM plant. And so I think that a major impediment to that type of work is resources.
So in order to bridge that gap between opportunity and funding, we need philanthropy.
The ability to follow bold ideas and not be constrained by a plan that they had to write out 3 years before that grant got funded is enormously impactful in making sure that we're bringing, the very best ideas to our patients.
I'm hoping that by the time my daughter Asha is grown up, that it'll be kind of a thing of a past, and we'll say, remember when this was something that, everyone had to deal with, but now you have all these standard treatments.
I'm living proof. I'm living proof of what the researchers had hoped and what they envisioned.
It's the high-risk, high-impact studies. That's the stuff that gets funded through philanthropy. Most of those ideas are going to not turn into the home runs that we hope that they will. But one of them will, and that's all that it takes.